Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to our very first flipped classroom video. What you're going to do is go ahead and take out that sheet that you picked up in class and go ahead and affix it and tape it down or glue it down into your interactive notebook right now. Please take the time to do this with me right now, because if you don't, chances are you will not have time later and you will forget. So while I do this, I just want to give you a quick reminder that remember, the best way that you can ensure and do your part to help continue this awesome new structure for class where you don't have to do homework by yourself at home, and you will get to do that with the class time instead, is to make sure that you really do take your time with these videos. Make sure that you are pausing and rewinding when you need to, and that you are actually doing the work alongside the suggested problems. Okay, so the first definition that we're going to review is an isosceles triangle. It is simply a triangle with at least, so it can't have more, but at least two congruent sides. Okay, so remember that this side is congruent to this side if they both have the same number of tick marks. That means that the third side is called the base. Okay, and the angle opposite the base, so directly opposite of this side, gives us this angle right here. It's going to be called the vertex angle. So vertex angle. So then the angles opposite the congruent sides are going to be called the base angles. So you can see that the angle that's directly opposite of this green side right here, so this side opposite of that side talks about this base angle, and the angle opposite to this side would give this base angle. So what we're going to talk about is two very important theorems that can help us solve problems, because if we know that if the two sides of a triangle are congruent, so if I know that this side is congruent to this side, then naturally I know, because it's an isosceles triangle, that it will cause the angles opposite of that side to be also congruent, so the base angles will naturally have to be congruent. So if this side is congruent to this side, then the angle opposite to this side, which is this angle, will have to naturally be congruent to the angle opposite of this side, which is this angle right here. So if you know the reverse, so if we start out knowing that the two angles of a triangle are congruent, so if I know instead that this is congruent to this, but they don't say anything else about the sides, the cool thing is then I can go ahead and make that assumption and say that it's going to be isosceles, meaning that this side that's opposite to this angle will also be congruent to this side that's opposite of that angle. Okay, we're going to move on to some examples that's going to show us how to use these theorems. So in the very first example, they show you that if you know something is an isosceles triangle, meaning all you know is this side is congruent to that side, then you can assume naturally that this angle, which is opposite of that side, is going to be congruent to this angle, which is opposite to that side. So I'm going to set up an equation here where it shows me that this angle is equal to this angle. And then you can go ahead and pause the video at this point and try to solve and see if you get the same thing as what I get. Guys, you should have gotten x equals 7 after you solve for x. So make sure you always read the problem. If they're asking you at the end to find an angle specifically, we found x but not the angle. So go back here to your picture and see that angle E is actually 3 times of whatever you found x is, which is 7, plus 14 more. Okay, so then you can go ahead and find that value. You should have gotten 35 as the measure of angle E. Okay, so I'm going to do one more down here where they want you to find the measure of angle C. So if you know that this side right here is the same as the measure of this side right here, then you know it's isosceles. And if these two sides are the same, then we just saw that it would cause this angle to be the same as this angle. So the angles opposite each side would have to naturally be equivalent and congruent to each other, which means that whatever measure this is, so I don't know it right now, let me assign it a variable, say x. If whatever this angle is, this one also has to be the same amount. So if I name this x, I get to also name this x. So then now that we have those labeled, it helps us use the idea that the angles of a triangle, the triangle sum theorem says the angles of a triangle all add and sum up to 180. So I can say that 78 plus this angle has to equal 180. So I'm going to pause again, and you are going to try to solve that out yourself. All right, you guys should have gotten x equals 51. So seeing as the measure of angle C is just what x equals, so I just already found the answer that the measure of angle C is just 51 degrees. And remember that there's lots of ways that you could have solved this or thought about this. You could have also done 180, take away 78, and said, okay, I have 102 degrees left for these two angles, and since I know they're the same, I'm just going to split that in half. Okay, so I'm going to leave this problem as a you try problem, and after the whole video is over, I would love for you to come back to these and try to see if you can do them by yourself, and check the answers with the answers at the end of the video. So we're going to move on to the next page that you picked up in class. So go ahead and tape this down into the next page in your notebook. For example 3, we can use our triangle, our isosceles triangle theorem again, because we see that this side is congruent to that side. So naturally the angle opposite to this side is this angle is going to have to be congruent to the angle opposite this side, which is this angle. So this angle has to be the same as this angle. And so knowing that, I am allowed to set up an equation saying that this angle, which is 8x, is the same as this angle, which is represented by 6x plus 18. And with some simple solving, I can find out what x equals. So now that I know what x equals, I need to make sure that what they're asking me is actually calculated out. So they said they want the measure of angle h. So here's the measure of, this is angle h represented by 8x. So I have to go ahead and plug in my x, which is 9. So instead of 8 times x, I have 8 times 9. And I have to get my final answer of measure of angle h is actually 72 degrees. Okay. Number 4 is going to be another you try problem. If you feel like you really need to practice this skill, then I would definitely make sure that I try that by myself. Okay, we're going to go on to our last corollary for today, which is really quite simple. All it says is if a triangle is equilateral, so if I know that this side is the same measurement of this as that side, and the third side of all 3 sides are the same of a triangle, then it's naturally also going to be equal angular, meaning this angle will have to be the same as this angle, which will be the same as that angle. Okay, and the opposite is also true. So if they don't start out by giving you these sides and they tell you that all the angles are the same, then you can assume that all the sides are also going to be the same. So we're going to go ahead and do 2 examples. Okay, so the very first one right here, they show you that this is an equilateral triangle because they are telling you that the sides are congruent. So then you can assume that all the angles are also going to be the same. So there's 2 ways to approach it. The first way is to say, okay, I know that all the angles of a triangle adds together to 180 degrees. So if they're all going to be the same, then I can just divvy this up into 3 and divide 180 by 3 because they're all going to be the same. So you find out that each angle has to be 60 degrees. So whatever they give you as the measure of one of the angles, you're allowed to set that equal to 60 because you already know that this is going to be 60, this is going to be 60, and this is going to be 60. And then you can go ahead and solve for x that way. If that doesn't quite make sense to you, there's another way that you can imagine this. So if you look at example number 5, same idea. They tell you that this is the same as this is the same as that. They tell you it's an equilateral triangle, meaning they're talking about the sides, so that you can go ahead and make the next conclusion, next jump in thought and say, okay, that means that the angles also have to be the same. This has to be the same as this, has to be the same as this. So you can finish the picture first before setting up an equation. So in this strategy, I can say if this is 5n, this also has to be 5n, and this also has to be 5n. And then you can say, okay, I have all my pieces of the triangle. I know all the angles. I have represented them all with something. So I know that all the angles add up to 180. So I can say this guy plus this guy plus this guy have to all add up to equal 180. And then you can solve your problem that way. So you will get 15n equals 180, divide by 15, and you should get n equals 12. And in this problem, that's all they wanted. So you're actually done with this problem, okay? So see what works for you, stick to that. I'm going to have you go ahead and finish the problems, and then you can check with my answers and see if you understood the concept. All right, you should have gotten x equals 33 on this one, vt equals 18, and mn equals 13. And on number 4, you should have gotten x equals 30. So then the measure of angle M is 60 because you plug in a 30 for the x. And then number 2, you should have gotten 47 degrees. Go ahead and make sure that you jot down any questions you have and bring them to class tomorrow.